So pH equals minus log H plus ion concentration. pH changes by 1 for every power of 10 changes in H plus ion. So a compact way to represent solution acidity when pH decreases as H plus ion increases. So that's pH. We know that pH equals 7, then neutral. pH is greater than 7, then basic. If pH is less than 7, then acidic. So that's their pH range. Now, we are going to calculate pH of some solutions, acidic solutions or basic solutions. Okay, so let's take an example. Calculate the pH for each of the following solutions. Okay, we have 1 times 10 raised to minus 4 molar H plus ion, and we have 0.040 molar OH minus ion, and we need to calculate pH. We know this equation, pH equals negative log H plus ion concentration. Here we have this H plus ion concentration, so we plug that in. So when you do that, then 2 minus 4, you get pH 4.00. pH 4. Now, in here OH minus concentration given. You know that Kw equals H plus ion concentration, OH minus concentration, and when we plug those values in, Kw we know that 1.00 times 10 to negative 14 H plus ion concentration, and OH minus concentration 0.04 OH minus concentration. So when you calculate H plus ion concentration, this one you can divide. So 1 times 10 raised to minus 14 divided by 0.04. So you get 2.5 times 10 raised to minus 13 molar H plus ion concentration. Now you know that pH equals negative log H plus ion concentration. So 2.5 times 10 raised to minus 13 molar, and you get pH 12.60. So that's the pH of that solution. Now we are going to work another problem let's say in here pH is given and we need to calculate H plus ion, other way around. Okay, so the pH of a solution is 5.85. What is the H plus ion concentration for this solution? We know that pH equals minus log H plus concentration, or when you find H plus ion concentration, we can say 10 raised to minus pH. And in here pH is given 5.85, so we can plug that 5.85 in here. So when you calculate H plus ion concentration, which is 1.4 times 10 raised to minus 6 molar, that's H plus ion concentration. So remember, I'm going to give you some of those equations just to recall, as a recall. We know Kw equals H plus OH minus ion concentration, and 14.00 equals pH plus POH. So now let's work on a few more examples. Calculate the POH of each of the following solutions. So we have given 1.0 times 10 to minus 4 molar H plus and 0.040 molar OH minus 1. Now, we know that pH equals minus log H plus ion concentration. So minus log 1.0 times 10 to minus 4, and you can say pH equals 4, but then we need to find out POH. So POH equals 14 minus 4, so which gives you 10. That's for A. For B, when you calculate, simple, POH equals minus log OH minus concentration and minus log 0.04 molar concentration, and you can calculate 1.40 POH for this B, for this solution. I'm going to give you one more example on it. Okay, so hold on to it. Let's work on the pH of a solution is 5.85. What is the OH minus concentration for these solutions? Now, pH is given, okay. So whenever pH is given, and we know that pH plus pOH equals 14, so pOH is 14 minus 5.85, so you get 8.15, and then you calculate OH minus concentration, which is 10 raised to minus 8.15, and you get OH minus concentration, which is 7.1 times 10 raised to minus 9 molar. That's OH minus concentration for this acid, for this basic solution. So you can calculate pH and pOH and H plus ion and OH minus ion concentration